everyone. Today we will see Cambridge IGCSE Physics Paper 3 Core October-November 2021. Here the first question is Figure 1.1 shows a plant pot falling from an upstairs balcony. The plant pot has a constant acceleration. Here we can see the plant pot is falling from the balcony. The first question is state the cause of acceleration. Here the acceleration is caused due to gravity. So the answer is cause of acceleration is gravitational force, or we can tell it as weight of the pot, and it is acting downwards. So the main cause, it is the gravitational force. Next, figure 1.2 shows the speed time graph for the falling plant pot. The plant pot hits the ground at time 1.8 seconds. So here we can see the speed time graph at 1.8 seconds. It is falling on the ground. Determine the height of the balcony above the ground using the information. So height here means it is the distance traveled. We need to find the height or the distance. So it is a speed time graph. We can find the distance by finding the area under the graph. So area under this graph will give the distance. It is a triangle. So we can use the equation half BH for finding the area. Half into B into H. Here it is half into, that is 1.8. The breadth it is coming as 1.8 here. And height, this is coming as 16. So half into 1.8 into 16. This will calculate and see. 1.8 into 16 by 2. That is 14.4. By rounding, we can write it as 14 meter. Next, figure 2.1 shows a pea plant. One of the pod is open, showing the peas inside. A food scientist needs to find the average diameter of a pea. She places 14 peas against a ruler as shown in figure 2.2. So here we can see she's placing 14 peas. Use the information from figure 2.2 to determine the average diameter of one pea. So we need to find the average diameter. So for finding average diameter, first we will measure the reading. Okay, the total length is 12.6. That is from here, this point 0.2, 12, this is 12.5, and this is 12.6. So the total length, it is 12.6. And for finding the average diameter, there are total 14 peas. So we can do 12.6 divided by 14. 12.6 divided by 14. That is 0.9. So the right answer is 0.9 centimeter. That is the average diameter of one pea. Next, the food scientist needs to find the average density of some peas. She uses the following values. Mass is given, volume is given. So density can be found by density will be equal to mass divided by volume. Here mass is given as 183 gram. Volume is 250 centimeter cube. So the unit will be gram per centimeter cube. We'll find what is 183 by 250. That is 0.73. So the answer is 0.73 gram per centimeter. Next, a different variety of P has a density of 0.89 gram per centimeter cube. One P of this variety is placed in salt water. The density of salt water is 1.02 gram per centimeter cube. State whether this P floats or sinks in salt water. Give the reason. So here we can see the density of P is less than the density of salt water. So when the density is less, it will always float. So the P will be floating. Why it is floating? As it is less dense than salt water. Next, figure 3.1 shows the horizontal forces acting on a skateboarder. We can see here it is backward 60 newtons and forward 100 newton. Calculate the resultant force. For finding the resultant force, we can just subtract. This is the forward force, that is 100 newton minus 60. So the resultant force will be 40 newton. And the direction, the forward it is more, 100 newton is more than 60 newton. So it will be moving. The direction will be forward, or we can write it is towards right. The direction will be to the right. Describe the effect of the resultant force on the motion of skateboarder. Here the forward force is 100. As it is more, the speed always increases. We can just see here, backward is 60 and forward is 100. So the speed will be more. The skateboarder is moving along a horizontal path. The backward force is 100 Newton and forward is 100. So backward is 100 and forward force also it is 100. So it is equal. It is in equilibrium. Describe the motion of skateboarder. So he'll be moving in a constant speed. Acceleration, as the force is same on backward and forward direction, there will not be any acceleration. He'll be traveling with a constant speed. Next, state the principle of conservation of energy. It is energy cannot be created or destroyed. This is the principle. Energy cannot be created or destroyed. Next, figure 4.1 shows a type of light bulb. Energy change occurs when the electrical energy is supplied to the light bulb. So the useful output is 50 joules. Some energy, thermal energy will be wasted. Input is 500 joules. Calculate the wasted energy when the total input is 500. So input energy was 500. And you can see here the output, useful output is only 50. So 500 minus 50 that is 450. 450 joule is wasted. Describe the effect of wasted energy on the air surrounding the light bulb. So here the temperature of the air rises. It is wasted as thermal energy. Some heat will be produced. Thermal energy is released. As a result, temperature of the air will rise or temperature of the air will increase. Next, table 4.1 lists situations in which energy is stored. Complete the table. So situation is given, form of energy stored, we need to write. Battery in a mobile phone. Battery contains chemical energy. It is being converted to electrical energy in case of mobile phone. Coal in the ground. So coal also contains chemical energy. A rotating turbine, that is movement is there, half mv square. Some velocity is there. So a rotating turbine means the form of energy is kinetic. Water stored behind a hydroelectric dam. That is, it is in a height. So it is gravitational potential energy. Gravitational potential means mgh. Suppose something is in height, that contains gravitational potential energy. Next, figure 5.1 shows two metal blocks. So we can see here A, B, two metal block it is there. That is which are same size, made of same material. This block A has a black in color and B has a shiny white surface. We can see the temperature cooling curve of the block A. So this is the cooling curve for block A. Using figure 5.2, determine the change in temperature of from block A from 0 to 2 minutes. So just we'll see the graph 0 to 2 minutes. So this is 0, this is 2 minutes. So what is the change in temperature? So this is the point here. So top it is 80. The 80 has been changed to this is around 55. This is the midpoint here. So this is 2, 52, 54, 56, 58, 60. So middle point, this one will be 52, 54, 56. Between 56 and 54, that is 55. So the change in temperature will be 80 minus 55. 80 minus 55, that is 25 degrees Celsius. Determine the final temperature of block A. So we'll find the final temperature. So here this is the final temperature for block A. That means you can just mark it like this. So this is the final temperature. That means 20 is the final temperature of block A. Explain why block A has a steady final temperature. Once it reaches the room temperature or surrounding temperature, there will not be any energy transfer. The room temperature or surrounding temperature will be around 20 degrees Celsius. So when it is reaching this one, there will not be any energy transfer. That's why the temperature has not been decreased. there will not be any further decrease, further change, or there will not be any energy transfer. Next, the results for block B are slightly different from results for block A. Predict the cooling curve for block B by drawing the line. So we need to predict the cooling curve. Actually, black objects have high emission. As a result, the black body will cool down relatively faster compared to white block. So this will be, the cooling of white will be, rate will be less than black. So we can just draw a graph, that is line that is just above the graph of block A. Explain why the results for block B are slightly different from the results for block A. Here, block A is a, black is a better emitter. So block A means it is in black color. So black is a better emitter than shiny white surface. Due to their efficient absorption, they also emit radiation effectively across the electromagnetic spectrum. Next, figure 6.1, the circles represents molecules. The diagram shows the arrangement of molecules in liquids. In liquid, it is being shown. Show the arrangement of molecules in solid. So draw a diagram in the box above the word. So we need to draw here at least 10 molecules. So we know solids that are, there is no gap. They will be having some regular arrangement. So just we will draw the molecules with regular arrangement, and gap will not be there in the case of solids. It will be closely packed. Next, we need to draw the arrangement of molecules in gas. So there will be large separation in the case of gas molecules. It is not closely packed and the arrangement will be random. State the name of process by which solid is changing to liquid. Solid is being changed to liquid. That is called as melting. We know the melting of ice. Ice is being melted to water. State the name of process by which gas changes into liquid. That is condensation. That happens in the case of rain. The gas molecules are being changed to in the liquid form. Next, figure 6.2 shows a microscope used for viewing smoke particles in a small glass box. A bright light shines into the box. The box contains smoke particles and air molecules. So this contains smoke particles and some air molecules. A student views the smoke particles through microscope. The smoke particles are moving. State the name given to the movement of smoke particles. Actually, the random movement of particles in a fluid or a gas is called as Brownian motion. This motion occurs due to the continuous collision. So these molecules collide with each other and they will be bombarded. Continuous collision of gas molecules with the particles, causing them to move in a zigzag manner. In some zigzag manner, it will be moving, or an unpredictable manner, it will be these particles will be moving. So here the question was, state the name given to the movement of smoke particles, that is Brownian motion or random motion. Here we can see one smoke particle as seen with the microscope. Show how the smoke particle move by drawing series of line. It is actually random motion. So it will be moving. So there will be sharp changes of directions and the random motion can be observed. The temperature in the glass box increases. Temperature is increasing. Describe any changes in the movement of smoke particles. Actually, temperature is not increasing. Temperature is decreasing. So temperature is decreasing means its kinetic energy will reduce. Kinetic energy is reducing means collisions will be less. The particle will start moving slower. So slower movement of particles can be observed. Next, a group of students are taking measurements so that they can calculate speed of sound. You can see a teacher here, group of students is here. The teacher is having block of wood. So with the help of these blocks of wood, he is making sound. These students are having some stopwatch. So they are going to measure the distance. The teacher claps two blocks of wood together to produce a loud sound. The student measure the time interval between seeing the teacher clapping and hearing the sound. So here they're having three stopwatches. Calculate the average value. So for finding the average, 3 times it is there. That is 1.27. This is showing 1.27. This is showing 1.34. And this is showing 1.44. We need to calculate the average. So we'll add these three, then divide by 3. That is 1.27 plus 1.34 plus 1.44. This one divided by 3. That is 1.35. And this can be rounded off and written as 1.4 seconds. Next, state the name of the instrument needed to measure the distance between the teacher and the student. So teacher is standing here and students are standing here. So for finding the distance, we can use a tape. So a tape is used for measuring the distance. The distance between the teacher and the student is given as 415 meter. The average time for the student to travel between the teacher and student, it is 1.29 seconds. So we need to calculate the speed of sound. Speed is equal to distance divided by time. Here the distance given as 415 meter. divided by time is 1.29 seconds. 415 divided by 1.29. That is 321.7. We'll round it off and write 321.7, 320 meter per second. The diagram in figure 8.1 shows a ray of light traveling from a glass block into air. State the name of for the dashed line as shown. So this is the dashed line. This is actually normal. State the letter which indicates the angle of incidence. Angle of incidence means with respect to normal. The B is the angle of incidence. Next, state angle of refraction. That is refracted ray with respect to normal. That is E. The diagram in figure 8.2 shows an object and a thin converging lens. The two rays are drawn from the object to the lens. The point marked F are the principal focuses. Continue the path of two rays in figure. So we will continue this path. Just extended this line, the line parallel to the principal axis. This has been passing through the principal focuses. Next, we will draw this line. So we have continued the path. Next, on figure 8.2, draw an arrow to represent the image. Next, we need to draw an arrow to represent the image. So this is your image. This is I. Indicate the nature of image formed by the lens. What is the nature of image? We can see here it is smaller than the object and it is inverted. That is diminished and inverted. So it is diminished and it is in inverted position. Next, the circuit diagram in figure 9.1 and 9.2 shows two resistors connected to the battery. Here it is in series connection. This is connected in series and this is connected in parallel. All the resistors have the same resistance and ammeters are not having any resistance value. Compare the current of in ammeter by completing the sentence. The first point is the current in A1. A1 is this A1 and the current in A2. As it is a series network, the current flowing in this will be same. Current in A1 and A2 will be same. So here the answer is same as current in A2. Next, the current in A3. This is A3 is the current in A4. We can see here the A3 current, it is being split to 2. So this A3 is equal to A4, current A4 plus current A5. So A3 will be always larger than A4. Next, current A4 and A5. A4 and A5, we know the resistance value is same. So as the resistance values are same, the current flowing through both these will be same. This current will be equally split through A4 and A5. So this is A4 is equal to A5, same as the resistance values are same. If the resistance values are different, means the current would have been different, but now the resistance is same. So A4 and A5 will be same. Next, about A1 and A3. Actually, A1 is this current in this series network and A3 is for second network. We know the resistor values are always same. Here the resistance are connected in series. So the equivalent resistance will be R1 plus R2. And here both the resistance are connected in parallel. As it is equal resistance, we can write it as, it will be R by 2. R1 parallel R2. When both the resistors are same in a parallel network, the total effective resistance will be R by 2. And when total resistance, when the same resistance it is connected in series, it will be R1 plus R2 will be 2R. So here the resistance value is more. So resistance value is more means current will be less. I is equal to V by R, or Ohm's law, V is equal to IR, I is equal to V by R. So as the resistance increases, current decreases. So current A1, this current will be less than A3. Here the resistance value is less. Resistance is less in the case of this network and resistance is more in the case of this network. So current in A1 will be smaller than current in A3. Next, the lights in a room are connected in parallel with a power supply. State one advantage of connecting the lights in parallel. If you are connecting the lamp or light in parallel, both the lamp will be having same brightness because same voltage is dropped across both the lamp, so the brightness will be same. And if one fails, any one of the bulb fails, the other will glow. And the lamps can be switched on and off independently. The potential difference across these lamps will be same. Next, the circuit diagram shows a resistor Q connected to a battery. The current in the resistor Q is 0.048. Potential difference is given as 12 volt. Calculate the resistance. Again, here we can use Ohm's law. V is equal to IR. We need to find the value of R. R is equal to V by I. Here V is, or we can write V divided by I. And here V is 12 volt divided by I is 0.048. Divided by 0.048. That is 250. So the resistance value is 250. The unit of resistance, it is ohm. Next, figure 10.1 shows the arrangement for transferring electrical energy from a power station to homes and factories. Here, power station, we can see step-up transformer for stepping up the voltage, for increasing the voltage, and step-down transformer for decreasing the voltage. It is there. It is given to factories, homes, and all. Explain why this arrangement requires step-up transformer and step-down transformer. Here, step-up transformer is for increasing the voltage. When we are transferring in higher voltage and lower current, the power losses or energy loss will be less. And then we need to step down because in homes, our appliances and all, it is working in low voltage. So there we require low voltages. So here step up transformer is used. To increase the voltage and lower the current value. It helps in reducing the energy losses. Next, step down transformer. That is used to decrease the voltage. Actually, lower voltage is required. Low voltage is required in home appliances. Next, a transformer has 2000 turns in the primary. So primary number of turns, it is 2000 and 500 turns in the secondary. And the potential difference in primary is 240 volt. We need to find the potential difference in secondary. So the transformer equation, that is Vp by Vs is equal to Np by Ns. We need to find Vs. Actually, it is primary voltage is 240 volt. So Vs will be equal to Vp into Ns by Np. Primary voltage is 240 volt and Ns secondary turns it is 500 and primary turns it is 2000. It is 240 into 500 by 2000, that is 60. So the potential across the secondary coil is 60 volt. Next, figure 11.1 gives the information about the nature and charge of three types of radioactive emission, alpha, beta and gamma. So we need to complete this table. Alpha is helium nucleus. Alpha means it is positive charge. Beta, it is positive charge and it is it is electron. Beta, it is negative. Alpha is positive and beta is negative, and the nature of beta, it is electron. Gamma rays, it is an electromagnetic rays. Electromagnetic wave, and it is neutral in charge. Next, state which radioactive emission is most ionizing. Alpha rays are most ionizing. State which radioactive emission is most penetrating. Most penetrating means that is gamma rays. Next, here they're given an radioactive isotope and a table is being given. So we need to find the half-life of this one. So we will check this. Initially, it was 800. So for finding the half-life, when it is changing to 400, what is the time? Starting it was 800. So here it is changing to 400. So its lifetime, half-life, it is 4. It is changing from this initial amount to half of its amount in 4 minutes. So determine the half-life. That answer is 4. Next, predict the count rate of this sample at time t is equal to 14 minutes. So we'll take 14, that is when it is 2 minutes, the count rate was 560. When it was 6 minutes, we know the 4 is the half-life of this sample. So after 4 minutes, it has been changed to 280. Then plus 4, that is 10 minutes. After 4 minutes, it has been changed to half of this. That is 140. And again after 4 minutes, 10 plus 4, that is 14. Again, it will be changing to half of 140, that is 70. So the count rate will be 70. You can see here 560 by 2, that is 280. 280 by 2, that is 140. 140 by 2, that is 70. So here the right answer is 70 count per second. Thank you all. We will see in the next video.